So here are three problems, and then in all the three there is a certain pattern that is repeating. So once you see a pattern, okay, I can see one hand up. I think we'll take 30 seconds. Let's give time for everyone to have a look at the patterns. Okay. Oops. Okay, who would like to share something interesting that they might have seen? Okay, I see cow 2 3 hands. So your teacher can take a call. Yeah. Oh. Uh-huh. Uh-huh. Okay. So it goes like that. That's a very interesting observation. That's a very interesting observation. Good. Yes. Yeah. Uh-huh. They are the same. Huh? Okay, superb. So you mean 2 and 2 are same? 4 and 4 are same? 9 and 9 are same? Good, good. That's a good observation. Uh-huh. Uh-huh. Oh, okay. So this one is less than 50, this one is less than 50, and this one is less than 100. Okay. Interesting. Okay. Uh-huh. Okay. 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 Any more? Yeah, one more hand. Oh, that's a very, very interesting observation. So what she's saying is that if you add this 3 and 7, you get 10. Yeah. 8 and 2, it adds up to 10. 9 and 1 also adds up to 10. So, Rahul, I should say that you have got a really wonderful bunch of students over there. Huh? Very good observations. I mean, in no class of mine have students given so many observations. Okay, they give one, two, or maybe three, but these are many observations. So that's very good. Yeah. Okay. So I think we can have a quick round of applause for all of you for the good observations that you did. Yeah. Okay. Okay, so I have one more puzzle for you. So here I have the answers for these three questions. Okay, and I want you to look at the answer and then look at the question and see if you can, you can find some pattern between the answer and the question. So you can observe some relation, some pattern between the answer and this question. Again, some pattern between this and this question, this and this question. Some hands are already up. Shall we take maybe 30 seconds for everybody to, so that everyone gets the time to think? Ravle, I'm not able to see one girl who had shared a pattern. She is getting cut in the video, so maybe she can just come little inside. The one who's sitting in the front. Yeah, okay, now it's better. Okay, so now let's go for it. So, who wants to share? Uh huh. Uh huh. Uh-huh. Okay. Oh, 2 times 3 is 6 and 3 times 7 is... You mean this 3 times this 7 is this 21. Yeah? Now I want to check if that's going to work for the other calculation. So I'm going to check 8 times 2, 16. Is it working? Yeah. So like I said, it's a common pattern. So we need to check if that's going to work over here. So 1 times 9 is 9. So it's working. So good, good. So that's working perfectly. But before you said that, you gave one more observation. You said that 2 times 3 is 6. Did you mean this 2 and this 3? Okay, so then let's check over here. 4 times 8, is it 20? No. So your observation is working for this problem, but it's not working for, 9 times 1 is not 90. So it's not working for that. But nevertheless, it's a good observation. Yeah. Uh huh. Mm-hmm. That's you have said something which will be very useful throughout your life in mathematics. That is, if you multiply two odd numbers, you get an odd number. If you multiply two even numbers, you get an even number. Yeah, so this is very very beautiful observation. So I have a question for you. Now that you said this, I have a question. Here we saw two odd numbers, when we multiply we get an odd number. Two even numbers, when we multiply we get an even number. What will happen if we multiply an odd number by an even number? Even number. Are you sure? Will it work for any odd number and any even number? Yes. So let's try. I mean, somebody can just shout an odd number and then somebody else can give an even number. Okay. Okay. Even number. 5 times 6. That's an even number. Yeah, that's an even number. Yeah. So maybe after this class, maybe sometime today or maybe tomorrow, you can discuss that with your teacher. Maybe you can think, can we prove? Can we argue and say that, when we multiply two odd numbers, it will always be odd. If you multiply two even numbers, it will always be even. Or is it just, it's going to work for only few numbers? Is there some way if we can give an argument and we can prove it? Yeah. So if you can do that, then you can be considered as somebody who's you have seen lawyers arguing in courts, at least in movies. Have you seen lawyers how they argue? Yeah, to the jury they try to convince them, saying why it is correct. So if you can prove this correct, then you will be, you can be potential lawyers when you grow up. Yeah, if you want to. Okay, fine. Yeah, so coming back to this problem, any other observation? uh, I got a method for getting 21. Like my friend said, 3 times 7 is 21. But I'm still stuck with the 6 and 20. Yeah. Okay. You mean this 3 times this 2. Okay. So now I want to check if that's going to work over here. So if I do 8 times 4, do I get 20? No. So what is very important over here is that we need to look for a pattern that is common to all. Okay, that is common to all the calculations. Okay, somebody else. Uh-huh. uh okay, so you're saying 2 times 2 is 4, right? Can you just repeat once again? Sorry. Okay. So how do I get this 6 from this 2, or how do I get this 20 from this 4? Sorry? Okay. Mm-hmm. Mm-hmm. Uh-huh. Okay. So then if that's a very good observation, no doubt about it. But if that's the technique, then we need to check if the same thing is going to work here. If the same thing is going to work here. Are you getting what I'm trying to say? Okay. So I'll just give you a small, hint. If you look at this 2 and 6, there is some relation between 2 and 6. Look at this 4 and 20, there is a relation between 4 and 20. Look at this 9 and 90, there is a relation. Uh-huh. Mm-hmm. Okay. So that works here. My question is, does that technique work for these numbers? Uh-huh. Is she correct? Others, is she correct? Yeah, so 9 times 9 is 81. If you add 9 to 81, you get 90. 16, add 4, you get 20. 2 times 2 is 4, add 2, you get 6. Yeah, so so that's, is that simple? So let's say that I give you a question. Let me just write down a question, over here. Let me just write down a problem for you. So let's say that we have 58 times 52. So initially you saw two patterns. Some of you said that, if I consider this as a tens place, then the tens place digits are same, right? 5 and 5 are same. Yeah, 5 and 5 are same. And then if I look at the units place or ones place, if I add them, I get 10, right? So this was the first pattern that you all said. Yeah. So so here, if this is the case, I repeat, if this is the case, then what do you think should be the right side? What did we do? What did we do here? Look at these problems. 23 times 27, how did we get 21? How did we get 16? How did we get 9? Yeah, so you multiply 8 times 2, you get 16. And then what do you do to get your left side? Uh-huh. add 5 is 30. Yeah, so that's your answer. You're done. Let's try one more. Let's try a bigger number. Let's take 77 times 73. Somebody else would like to try this, maybe. Uh-huh. Can you tell me why? Three times 7 is 21. And left side, sorry, 7 times 49. 7 times 7 is 49. Then what do we do with this 49? Mm-hmm. Mm-hmm. Add 7, you get 56. Yeah. Yeah. So that's done. You're done. Yeah. Is this okay with everybody? Have you got the technique? Yeah. I think we can do it in one more way. To get this 56, I'm trying to recollect the table of 7, the times table of 7, the multiplication table of 7, and 7 times what number is 56? 8 is 56. Now I'm trying to recollect the table of 5. What is 5 times what is 30? 6. Okay. So just keep this in mind and we'll try one more problem. Let's say we have 84 times 86. Can you all work out the answer on your own? Yeah. 5,000. Okay. 7,224. So this 24 I think is clear, right? 4 times 6. Yeah. What about the 72? How did you get the 72? Yes. 8 times 8, 64, add 8, you get 72, right? Okay, superb. So again, let's think. 8, this, I got this 7 over here, I got this 5 over here. So I'm just thinking, if I get this 8 over here, 8 times what number is 72? 9. Do you see some pattern again over here? Uh-huh. 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 Yeah. Yeah. Good, 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 good. Very good, very good, very good. Yes, I think somebody else want to share something. Correct, correct, correct. So you can see here, to get the left side, to get this 30, we have got two ways. Either we can do 5 times 5 plus 5 and get this 30, or we can just do 5 times 6. So here we are doing one operation, one calculation, 5 times 6. But here we are doing calculation 2 times, that is 5 times 5 add 5. So we are doing two operations, right? Which one do you think would be faster for you? Doing one operation or doing two? Doing one? Okay. Uh-huh. So it depends from person to person. So I'll just give you some problems to just work upon. Let's see. Okay, so before we go ahead, this is the most important thing that we need to remember. In Vedic mathematics, we do calculations like this is one set of problems and this is one technique, and this works only if two conditions are satisfied. You see, these two conditions are very important. If these two conditions are not satisfied, we should not use this technique. Okay, so what are the two conditions? Yeah, yeah. So you have to look for these two conditions. Only if they are satisfied, you can use this technique. Otherwise, no. Is that okay? Yeah. So I'm going to give you a small quiz. If I write two numbers, you have to tell me whether I can use this technique or not. Okay? Can I use this technique for this calculation? Yes? So some of you said yes, some of you said no. So justify your answer. Because the units don't add up to 10. 6 plus 3 is 9. It is not equal to 10. And our second condition was the units place digits should also add up to 10. Yeah. So this does not qualify for your this fast technique. Okay, so that's a very good observation. What about 45 times 45? Does it qualify for this technique? Yeah. Okay. What about 83 times 97? So the first condition was that the tens place digits should be the same, 9 and 9, 4 and 4, 2 and 2. So that was the first condition. Do we have the condition satisfied over here? 8 and 9. Not the same. So we cannot use this technique. You see, what these techniques do to you is that it improves your observation. You start looking at calculations and then you start thinking, hey, can I use this technique, or will these conditions apply? And the more you think, the more you use your brain and the more intelligent you become. Yeah. Okay, so I want you to just keep these two conditions in your mind. Yeah. So let's go ahead. Now regarding the sutra that I was telling you about, I'll just quickly go through the sutra and maybe your teacher can do it in little more detail when time permits. This sutra is called, sorry, can you all read Sanskrit? Read the letters. Okay, okay. So I have, this is something called as transliteration. Okay, not translation, it is transliteration. So this is A-E-K-A, and when there is a line on top of A, it is a long A. It's called Eka, like that, Eka. Yeah, Eka. Eka dhi ke na. And then there is a line over U. You extend that sound, ooh, like that. Ooh, when you say ooh, you say U and you put a dash, yeah, on top of that. So ekadikena purve na. This is called na, na. Okay. So ekadikena purvena. So what does that mean? Ek means one. Okay, ek means one, and there is a word here called adhik. Adhik means more, and purvena means previous. So what it means is, this is the last digit, this ones place, so this is the previous digit, so you take one more than the previous digit. So what is one more than 4? It is 5. So that means you have to multiply 4 times 1 more than 4, that is 4 times 5, which is 20. Okay, so that's what it means. Okay, so this is another Upasutra that is dealt over here. I think we'll just, for the interest of time, we'll just skip this part and we'll try to do some quiz. Okay, so here we have eight problems, but I don't want you to do the last 4. I just want you to try the first 4. 56 times 54, 34 times 36, 95 times 95, and 19 times 11. So to make it a little challenging, can I put a time limit for this one? Just for the sake of doing it, let's say 2 minutes. Okay, yeah. So once you're done, maybe just you can raise your hand, and then we'll know that you're done. Anybody wants me to repeat the technique once again, or do you remember it? No, wait. Okay. Those who have finished, maybe they can think how they can do the 5th and 6th question. You can just give it a thought. Ravle, you can tell me when we can go ahead, when everybody is done. Yeah. Okay. So I think we can just discuss the answers. So the first one maybe you can check, and in case you got the first one wrong or any of these questions wrong, you can just raise your hand. You can share what's your answer, and others can correct. You know, let's go one by one. What about 3024? Anybody went wrong in 3024? Okay, so somebody would like to help your friend at the back. What was your answer? Sorry. Oh, you wrote 324. You missed out that zero. Okay, that's okay. What about the next one? 1224. Anyone got it wrong? Okay. So next one, 9025. Okay. What about 209? Ah, I knew that this was, in cricket there is that Yorker ball. Yeah. You all watch cricket? You don't watch cricket. You don't watch cricket. Oh, you watch cricket. Yeah. So you see bowlers when they bowl a Yorker. Yeah. So in Yorker, they usually get a wicket. Yeah. So this was the kind of Yorker ball I had for you all. Maybe your answer was 29 instead of 209. Was it so? 29. Yeah. 29. So tell me, how did I guess that you would get 29? How did I know? I can't see your notebook from here. So can you make a guess? How did I know? Uh huh. Uh huh. Okay. Mm hmm. Mm hmm. Yeah. 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 That's perfect. Perfect. So what we need to remember here, which I didn't tell you earlier, that the right side of the answer, like when you do 6 times 4, you get 24. It's a two-digit number. 4 times 6 is 24. Again, a two-digit number. 5 times 5, 25, two-digit number. 3 times 7, 21, two-digit number. So in this technique, the right side should always have two digits. Okay, it should not have less than two digits nor more than two digits. So when you do 9 times 1, you get a single digit number. So like what she said, how do you make a 9 as a two digit number? So you place a 0 before 9. I would like to use the word place 0 before 9, not add 0 before 9, because we are not actually adding, we are just placing a 0 over there. Hey 0, you go sit there. So that's what we are telling it. Yeah. So 09. Is that okay? Yeah. Can anyone guess how this can be done? It's a three digit number calculation. Three digit. Okay. So who wants to try? Ravli. Uh huh. Others, what do you think about this answer? Is it correct? Can you just repeat? Yeah, that's correct. Let's see if that's going to work here. Uh huh. At 20, it's 420. Yeah. Yeah. So can we do this in the second way? 10 times 1 more than 10, that is 10 times 11. Yeah, yeah, 10 times 11 is 110, and if you do 20 times 21 you will get 420. Yeah, same thing. Sure. Okay, so this was about one technique, and I just thought I'll share one quiz. We can do something like this. Let's say 5 6 1 6. This is multiplication of two numbers that come under this pattern. So can you figure out what the question is? So I have something reverse for you. Till now you were doing question, and I would give the question, you would find the answer. Now I have an answer. Can you figure out the question? Yeah. So we can take a minute maybe. I can put one more problem over here so that those who finished can think about the other one. The clue is it follows the pattern. It follows the pattern that we just saw. Okay. Both these problems follow the pattern. Okay, some of you got the answer already. Okay, so Ravle. Uh-huh. 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 7 and 7 8. Now what do others think? Is this correct or wrong? But I have a doubt. I'm thinking maybe I have 7 4 and 7 4, and 4 times 4 is 16, 7 times 8 is 56. So why can't the answer be 74 times 74? Yeah. So if you, because 4 times, sorry, I didn't hear it very clearly. Sorry. And it does not satisfy the second condition, that the units place digits should add up to 10, but 8 times 2 satisfies the second condition, so this is correct. Yay, it's correct. Okay, so okay, so next one, somebody else, maybe somebody else. Uh-huh. 5 times 5. Now others, what do you think? Is it correct? Are they correct? Yeah. So 8 times 9 is 72, or 8 times 8 is 64. Add 8, you get 72, and you have 5 times 5, that is 25. Yeah. So you see, what you have solved is it's a very challenging puzzle. It's not a very easy puzzle, but because you knew this pattern, you could try to see, okay, can I use this pattern and can I solve? But you have to be very careful. You should not use this for anything that does not follow the two conditions. Okay, so both the conditions, that tens place should be same, and units place should add up to 10, that should be satisfied. Yeah, yeah. Hmm. Absolutely, absolutely. So you're saying how do we do, suppose we have something like 72 times 73, is that your question? How do we do that? Or or is your question like, can there be other set of answers which can be 7225? Like for example, if I give the question as 1089 and I ask you what are the numbers over here, can it have a different answer? Can it have multiple answers? Is that your question? Ravle, maybe you can. Okay, that's your question. Yeah, so that's a very very good question. Like for example, if we do, let's try 24 times 26. Okay, so here what will be my left side? Can somebody tell me left side? 6, and right side 24, right? Now let's say I divide this number by 2 and I multiply this number by 2. Then 24 divided by 2 will be what? 12. And 26 multiplied by 2 will be what? No, 20. Think about playing cards. Yeah, 52. If you play cards, then you can know that there are 26 red cards and 26 black cards. If you add, you get 52. Yeah. So if you multiply 12 and 52, what do you think will be the answer? 624, because here we have divided by 2 and here we multiplied by 2 and we are multiplying the entire thing. So here we'll have the same answer. So like what she asked, we can have different questions for the same answer. It is quite possible. So that's a very beautiful thought. In fact, I made a mistake in framing the question. Maybe I should have said, can you figure out at least one solution for this puzzle? Yeah, because here as we can see, there are multiple solutions, multiple answers. It can be this as well as this. Okay, so before we take a pause, I would just like to give you one thought. Let's say that you want to find area of a square. Have you started learning area of shapes, finding area of geometrical shapes like squares and all? Have they started, Ravle? Okay, at least for square they know. Yeah, okay. So let's say that my side length is 15 and I ask you what is the area of the square. What will you do? Yeah, multiply. So now I give you 5 seconds to give you the answer. Can you figure out the answer in 5 seconds? $60. Think again. Oh, I think how you got 60 is maybe you were calculating the perimeter. Yeah. We are trying to find the area. 225. 3 or 2? Okay. 325. Okay. Can you tell me how you got this 3? So what do you get? 1 times 1 plus 1. 2. So shall we just correct this? Shall we? 225. You see here, this 15 times 15, it follows the pattern, right? the tens place is same, the units place adds up to 10. Does it follow the pattern? Yeah, it follows the pattern. So the moment we see it follows the pattern, we can use this technique. Let's say that instead of 15, suppose it was a bigger square, and let's say the side lengths were 35 and 35, and you want to find the area of the square. So what do? Does it follow the pattern? Does it follow the pattern? Yes. So what will be the right side? 25. And what's going to be the left side? 12. Yeah, so we got the answer. It just took maybe what, 3 seconds, 4 seconds, we are done. Yeah. Yeah. So can we use this for doing something like 75 times 75, 85 times 85, 95 times 95? Do all these numbers follow the pattern? Yeah. What about 74 times 74, 84 times 84? Do they follow the pattern? No. Yeah. So we can use this for numbers ending with 5s, right? We can use this for numbers ending with 5s. Yeah. Okay. So yeah, Ravle, we can take some quick questions in case they have, or otherwise, shall we take a pause? Little. Sorry, I couldn't hear it clearly. Mm-hmm. Yeah. So how do we do 74 times 84? So what we did is just one technique in Vedic maths. Okay. So like this, there are many techniques in Vedic maths using which we can do calculations really faster and using different ways. And after you learn some techniques, you'll see question like, for example, 95 times 95. You can do it in 3 different ways or 4 different ways actually. So each person can choose their favorite method. Somebody feels that this is good for them, they can do this. Somebody wants to use a different method, they can use that. So there are alternative methods where you can do 74 times 84. We'll have to spend some time to discuss like how we did now. We'll have to do that. I think you already have Vedic math in your school curriculum, so maybe you might encounter these techniques later on. Yeah. Okay. But this is the question that should come to the mind, that you should be asking, hey, you tried showing us all these techniques with certain numbers, but what if we don't have numbers in those patterns? So how do we go about it? Yeah, that's a good question. Yeah, that's it. Okay. 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 Yeah. Okay. So, Ravle, I had a wonderful time with your children, and I hope they also enjoyed a bit doing these techniques in Vedic math. Hey. My pleasure. Bye bye. Sure. 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 Okay. Okay. Thanks, Ravle. Thank you. Bye bye. Bye. Bye.